Okay, hello everybody. This is Mike Overthrew here again. So today I have a really cool guest, uh, RZ out of China, and he's got a really new Kickstarter he's doing for his kind of next step in the open cat, and it's the Biddle. So I'm gonna let RZ kind of take it away, kind of introduce himself and his project, and uh, how to get started on a little quick interview.
Hello everyone, I'm RZ, and I'm the inventor of OpenCat and Nibble, and now the robot dog Beetle. Um, I'm a physics PhD and computer science master. I studied in Wake Forest during 2010 to 2016. And in 2016, after my graduation, I just got a chance to buy a Raspberry Pi and learned to program hardware. Since then, I started the OpenCat project and built a working cat with some regular components from Arduino or Raspberry Pi kit. So I was a software guy, but with those tools, I was able to build some sophisticated devices like this cat. I initially started this project just like a hobby, but because this was so fun, I got addicted to this little cat, and in the end, I decided to make it my career. So in 2018, I quit my job at Wake Forest and moved to Pittsburgh to try to bring this little cat to everyone. And I launched an Indiegogo campaign toward the year end of 2018. It was successful. And after that, I have been busy with the manufacturing of the cat and delivered all the orders to our backers. In 19, I moved back to China because it's more close to our supply chain. This year, I moved to Dongguan. It's an industrial city with a lot of factories around. I'm living in the factory right now for the research and the development of our new robot dog. And I launched the Kickstarter campaign for Beetle Dog last month. It's just 2 weeks since then, and we have already fulfilled the 50K goal, and it's now $260. Okay, yeah, it's a great campaign. It's a great start. And today I'm very happy to have this chance to share more of this project with you.
Yeah, this might be a technical thing, but your video is really choppy on my end. I'm hoping the recording is actually recording you and we can see you. I hope it's not something goofy going on with Skype.
Shall we pause this and check what's recorded so far?
Yeah, let's try that because I'm worried. I don't want to waste your time. Because right now the video is freeze framed.
Okay.
So let me stop and see if we can see what the recording looks like.
Sure.
Okay, hello everybody. We're back with RZ from China, talking about his really cool Kickstarter project. And we may or may not be having technical difficulties, so we'll just kind of try to get through them and get this recorded. His time is valuable for him. So you kind of talked about yourself and how you got started, what you've been doing. So can you kind of jump into your new Kickstarter? I know you said that so you're over 260,000 now. I know we're I think 1,000 backers. You got like 21 days left. Oh, the big thing I was going to ask you about is, do you have any stretch goals that you're going to be adding to your campaign?
The initial goal was 50K, and it was fulfilled on the first day. So we added a stretch goal right after that. We set it as 20K, no, 200K. Yeah, and then it was fulfilled on the sixth day. That's amazing. And at that time, we set the goal, like if we achieve the goal, we will provide one free groove unit, groove sensor, or other gadgets to every Petoi kit. And after we fulfilled the first stretch goal, we're still considering a new goal and a new gift because everything happened so fast. I think we will again provide another groove unit or some better ideas.
Okay, cool. So you had talked about maybe having different color variations, because right now you've got it's black and orange, but you talked about maybe doing black, orange, and blue.
Yes. So currently we are already making two color themes. One is black and yellow, and one is black, yellow, and blue. Because the mode, to save the budget, we combined several parts onto the same mode. That means the color pattern is pretty fixed, like the like this head and the shoulder has to be the same color because they are on the same mode. But we can change the colors, like change this blue piece because these two are on the same mode.
Okay.
Yeah. And because for setting up the injection molding, you will need to prepare all the different colored materials into the injection machine. And for every batch, you would expect more than 100 sets of the frame. So we may not be able to be that customized like just one set of red dog. But if there are demands like over 100, we may be able to make it more customized.
Okay, very cool. So I've seen some other videos and some other interviews that you've done, and you've kind of done it pretty cool. It's almost like a snap together kit. So you've taken, like this sounds like you prototyped your parts using a 3D printer, and then you've invested in the molds for injected molding, and the parts actually just kind of all snap together. So the assembly should be pretty easy for everybody. Instead of doing lots of really small screws, you just basically have a snap together kit, which is a very cool idea.
Yes, because I realized that if we have too many screws, people may have difficulties in assembling them, and it will also put some difficulty on our side when packaging.
Yes.
By the way, I invented a little tool to sort the screws. You know, if you just pick them by hand, it will be very slow and you may have mistakes. But I made a little tool with a lot of holes on the board, and I pull the screws into the box and shake. All the screws will drop into the holes so that the count will be accurate.
Okay, very cool.
And fast, yeah. And for this structure, I did a lot of validation with 3D printing to make sure that the structure works, and I try to use the highest resolution I can get on the 3D printer. But still, 3D printing is less precise than injection molding. So we did it with caution by making the mold slightly smaller than the size. So it will be loose when you assembling them. Then we can just cut more from the mold to make it tighter and tighter, because you cannot do this process reversely. Yeah, it takes a lot of time. The whole process for me, I have to redesign this redesign the structure because there are also some other principles you need to consider when designing injection mold. For example, the structure has to have a certain angle so it can be pulled out. Yeah, a lot of this to consider. I redesigned the model in 1 month, and then for the following 3 months, I just communicate with the engineers in this factory to make the mold.
Are you eventually going to let people download the files so they could maybe modify or 3D print them out, or what's your plan in the future for that?
So for our backers, if they need some parts, I can share the design files with them. And the problem with 3D printing is because one is the precision. It may not fit this structure very well, and also the strength and the elasticity. There are several parts I'm utilizing the materials like this head. In my design, there's no spring structure, but
Okay.
it's still able to click. And
Right.
if I print it, I have to use the highest resolution to get this part smooth, so it will not scratch on the back, but still the elasticity will be bad and the material will crack. But
Okay.
I think, yeah, on one side, I can share the design file with our backers if they want some replacement, but I will not share the whole set just in case some copycat will get it and build another company against me. And I can also share the model before we make the injection mold.
Okay, cool.
Yeah, that's for 3D printing.
So for the people who know me, my background is in humanoid robots, and been doing it for over 10 years. So when I have a new humanoid robot, or working on design for new humanoid robot, the servos are always very important to the robot as far as making it work well, making the moves smooth, making the moves workable. So the servos kind of make or break, in my opinion, can make or break a robot. Can make a cool robot bad, and an average robot really good. So can you kind of, I know you've talked a little bit about the servos in other chats, but can you kind of get more in depth about the servos? Are these custom servos that you're making for the robot? Do they have what, metal or plastic gears? Do you have any specs on the speed and the holding torque?
Sure. And before I answer your question, you said many servos would break in your previous experience. Where do they break the most frequent?
Well, yes, they can have issues. I guess what I'm trying to say is that not really break, but a really cool looking robot that has really bad servos, has low torque servos, has a lot of backlash. That robot is not, it doesn't walk very well. It's hard to get it to do moves. But with a robot that maybe doesn't look super cool, but has nice, strong servos with limited backlash, good holding torque, it's a lot easier to make motions, walking motions, running motions, or so on. So, I mean, the great examples, I don't know if you've seen like the Kondo humanoid robots out of Japan, or the robotics humanoid robots out of South Korea, like the Darwin, the robotics OP, and the Kondo robots. What makes them so cool, it gives them great running gaits, walking gaits, is the ability for the servos, like I said, to have limited backlash, and then you have to do that balance between holding torque and speed. I think you've talked to this to other people about how you've amplified the speed, but like I said, it's to me, servo is always one of the most important ingredients in for a robot.
Mm-hmm. Yeah. So you know this guy, right?
Yeah.
This is a super cheap plastic servo, and I built my first cat with this servo. They break every 5 minutes. So like in 10 minutes, all the cat will all the joints will break. So later on, I decided that the servo must have metal gear.
Okay. Cool.
That's the lowest requirement, metal gear. And then it has to have the digital control board. Some are just using analog, but we are using digital PWM. So it will have better control precision and more stable. And then when I was in the US, I looked for the Tower Pro servos. They are metal gear and allow a higher voltage. Like when we are using two LiPo or Li-ion batteries in serial, they will generate 8.4 volt to 7.2 or 7.4 volt. For these plastic servos, they will burn.
Right.
Yeah, initially I designed the circuit board to have a potentiometer to tune the voltage between like 6 volt to 8.8 volt in hope that we can be compatible for these little servos. But it turned out that the step-down chip will not be that efficient. And sometimes when you like hold the servo, it will get to a store torque. That means the current will go up to a peak, and that peak will trigger the protection of the step-down circuit and basically reset the board. That
Right.
will introduce some unstable factor into the circuit. So finally, we decided just to use the battery to drive the servo directly. That means the servo has to be able to bear the high voltage. So that's another part to consider. And ball bearing, if the output shaft has no ball bearing, then it may shake and it may not that good. So it's also one consideration. So with all that consideration, we found our first manufacturer for the Nibble cat after I returned China. Yeah. And I would say that currently, if you are just looking for regular servos on the market, they are not optimized for walking robots, because traditionally servos are used for like steering the aircraft or ship. They are just for directional purpose,
Right.
not for like driving, carrying the whole body weight of a robot. At the same time, you ask for the precision is not optimized. So after I visited those factories, I was able to let them to fine-tune the parameters. And by the way, it's actually very hard to get them agree with that, because all those manufacturers are looking for some larger orders.
Right.
Yeah, they are not interested with small orders like 100 servos. They don't want to waste time on that. So I got the benefit because we are actually making this as a product. They can see the sales data. And what makes them even happier is I just told them a good picture. That if this kind of robot will get popular, if we sell one of these robots, they can sell 10 servos. So potentially this is a huge market for them. So they are more willing to help me to fine tune these parameters for the working purpose.
Okay. Very cool. Yeah. So yeah, I've experienced everything we've been talking about in my days doing humanoid robots. So like the Kondo servos and the robotics servos are especially designed in-house for robotic activities. So and since they have huge volumes, like you were saying, they're able to make the servos cheaper and better. So it's good to know that you'll be making servos that enough servos so people can buy extras from you. Even the best companies, you can easily smoke a servo after hours and hours of usage. So it's always good to have backups and the ability to use ones. And you said they were digital. Are your servos daisy chained, or do you have to connect each servo to the control board?
Each to the control board. It's PWM, not serial. Yeah.
But they're digital, which is good.
They're digital, yes. And we plan to develop some customized serial servos. The consideration here is how do you index the serial servos? If we keep this robot as a kit, then there may be some troubles for them to get indexes. Because I don't want to mark the servos with like 1, 2, 3, 4. It will be very easy if you mixed 1 or 2 when you are putting them, when you are packaging them. So the benefit with this PWM servo is all its indexes depends on where you plug onto the control board. I think it's easier at current stage.
Right. Very cool. So you kind of talked about this in some of the other interviews, but so I always think servos first, and then when I talk to people interested in robotics, usually their first question to me is, how do I program the robot? Now, I know you've said in other interviews that you've designed the robot not for kids, but for more educated people who are into programming stuff. And to me, that's kind of cool because you know about bipredominant spot. Everybody wants their own spot, or a big dog to play with. So that, to me, that's actually a selling point for your Kickstarter. But can you kind of talk really quickly, kind of give an overview of your programming environment? I know you have a Scratch base or similar to Scratch base programming environment and an Arduino programming environment, and then you also have Python.
Yes. I developed the first robot, first prototype with Raspberry Pi. So initially, all the code was written in Python. But later, I realized that because the Python code was running on a Raspberry Pi, but a Pi is a computer. That means it's running multiple threads. It's not focused. It will check email. It will check network connection. It will listen to the keyboard, all the stuff. That means all the threads, sometimes the pace is not consistent. But the rhythm of walking is very important when you are trying to keep balance in a periodic motion. And also, although Pi has the benefit of running some high-level applications like OpenCV, for vision, it will take a lot of system resources to make the thread arrangement even worse. You will see some laggy behavior when the camera is working. Right. So later on, I just decided to separate the motion code out and put it onto an Arduino, because in an Arduino, it's usually a single loop microchip. The real-time performance is better. So I started to learn Arduino. The benefit is I was a software developer, and I'm very familiar with C, especially in optimizing the memory management in data structure and algorithms. So I was able to fit all the motion code onto a chip that's on a Arduino Uno, the most popular and simple chip. It has very limited resources, but with my algorithm optimization, I was able to fit everything onto that chip. And I can share you the screen of my coding environment. You see it?
I just don't know Skype that well. I've actually seen your shared screen a lot better than you.
Okay. So this
yeah.
is the Arduino interface, and you can see this is write instinct, and OpenCat.h. So the software, the whole logic of the control is that I separate the motion part to the Arduino board, and the Arduino board then becomes the motion controller. Similar to human or other animals, we have a central to control basic patterns, and you don't need to consider all the details of the motion. How do you control detailed leg joint? It's just instinct. So all this instinct is written with this write instinct code. You can see this instinct H is some pre-trained data to define how walking should happen. And there are also some static postures. They are just one frame. You can imagine this robot as a CD player. I define all the drivers of the CD, and you just insert the CD disk and to play it. For other users, they can also design their own postures or walking gaits and just put it onto this robot and let it play all the posture frames. And it will be much cheaper than you build a hundreds of $K robot, and which may break very frequently or very hard to set up. And the program has two stages. One is to write the instinct to the board. The second will be the main control program, nibble. Because when you are writing huge amount of data to the Arduino, it will take up all the flash. So I have to write the data first in the second round onto the external memory, which is an EEPROM chip. And the second loop, I write all the control algorithm to it. And then this main code will define how it listens to infrared remote signals, how it parses signals from the serial port, and how it will load the skills, how to balance, and other control logic.
So do you have, so this may get too deep in the weeds for some people, but do you have like a walking gait that's dynamic? That because I know on your board you have accelerometer and a gyro. Is that correct? Do you have? So do you have a dynamic walking gait that uses the input from the gyros and accelerometers to bounce the robot out?
Yes. The current movement of this cat is a combination of static postures or static gaits with the adjustment from the gyro data. You see?
Right.
Yeah, it can self-write.
Awesome.
Yeah, and it can walk. Like this is a crawling gait. You can see it's still trying to adjust if you tilt it, and it can be accelerated.
Very cool. Very cool.
And try this walking gait. For this little cat, because it's wooden and the structure may not be that strong, so I limited the accelerated loop to only 5 loops. It will work turbo for 5 loops and then return to regular speed. And also you can design other motion patterns.
Very cool.
Yeah.
So when you're programming and you set all the servo positions and so on, is it kind of like a clay motion movie where you do small incremental changes to the servo positions and then build the walk? Because that's like a lot of humanoids. What they do is like a claymation movie or stop camera motion movie where you have a model and you move it slightly and then build the gates. Do you understand what I'm saying?
Yes.
Is that similar to how you're doing the gates for the static gates for your cat and your dog?
So there are two ways to design the continuous motion. One way is that you mentioned the clay stop motion movie. You just put the postures to this angle and to this angle, and you may interpolate between those positions. That's good for static motion, like the waving behavior is done in that way. But for walking, it's actually more complicated because when you are walking, you need to consider the balancing and how to coordinate, how to collaborate all the legs for walking. So I actually designed an algorithm to do that.
Okay.
Yeah.
Because a lot of people use kinematics.
Yes, I did
Yeah,
that.
yeah, especially like the dynamic for a dynamic walk. It's like for a lot of people, if you don't know what that is, a lot of Pixar uses kinematics in that you can when you move a character, a cartoon character around a screen, it uses kinematics to adjust the joints of the robot, the cartoon character walk around. And the same thing with the not static, dynamic walking. And then you have the input from your gyros and servos to help balance the robot
Yes.
edison. Well, actually, I do the humanoid, but as you're doing the walking, you can, and as the surfaces change underneath it, it'll.
Yes.
That's cool.
Yeah.
Very
Yeah, another way to generate the motion is by using some approximation of solenoid functions, triangle functions. For their solutions, they may only be able to move these little steps because they are using the approximation that the sine alpha equals to alpha when the angle is small. But in my robot, because I'm using the inverse kinematics, it can take larger steps.
Oh, I forgot to ask you this question. So I've noticed on your robots that you have springs.
Mm-hmm.
You usually have two springs in each leg. Is
Mm-hmm.
that does that help with torque, or does it help with feedback, or exactly? I'm just curious why you added the two springs to the legs. What does that do for you?
Mm-hmm. This spring is one of the innovative parts of my whole design, because for other robots, especially on this small scale, they are just using direct connection. I used the direct connection when first building these robots, but I soon realized that the rigid connection is very bad for the servos. Any collision, any shock on the foot end will be applied to the servos, and the servo will break very soon, or it will shake because the gap between gears will be increased after a period of use. So I introduced the spring into the structure. You notice there are two springs along the upper leg. And because the lower leg is almost perpendicular to the upper leg, that means these two springs can handle torque from all directions and flatten the shock on the servos. You can
Okay.
see even I drag this, the actual shock on the servo gears will be very small. And it can absorb some little shock when it's stepping on something to make it smoother, and it will also elong the lifespan of the servos.
Okay. Very
You can
cool.
see, yeah. And when paired with some adjustment in the software, you can see it's like a soft robot.
Awesome. So so that's the Arduino programming environment. So can you talk a little bit? So you've said in the Kickstarter you had talked about maybe using the Raspberry Pi as an add-on to the robot.
Mm-hmm.
Could you, since we kind of sort of talked about the Raspberry Pi, could you kind of go on that a little bit so you have a connection from your controller to a Raspberry Pi? What would you envision using the Raspberry Pi for? For vision processing, for high level, for like navigation,
Mm-hmm.
navigation?
Yeah. So remember my original code was written all in Raspberry Pi, and I just separated the motion part to
Right.
the Arduino. And later I realized that maybe people are the most interesting part of this robot is the walking part, and people may only need to be able to control the robot to walk around. So this Arduino board becomes a single product in our standard kit. But what if people want to add more functionalities? They will need a more powerful chip. It could be a Raspberry Pi, it could be other microcomputers. So I kept the support for Raspberry Pi. You can see there is the 2x5 socket on this on our customized Arduino board, and you can see this cut is designed to allow these pins to be exposed. So
Right.
if you connect these two, this socket will provide power from this Arduino board to power on this Pi, and it also has a serial port and I2C port to communicate between this Pi and this motion board. Now the Pi becomes the brain of this robot. You can run all kinds of applications directly on the Pi, like voice recognition, vision, networking, and then communicate to this Arduino board to send motion signals. For example, if you hear the command sit, the Pi will handle all the translation work and just send the string token sit to the motion board, and the motion board will take the action.
Okay, very cool.
Yeah, and later on we also have this Bluetooth dongle.
Right.
Yeah, it can be connected to this tail. This is the port for uploading Arduino codes. It can also allow to plug this Bluetooth dongle to communicate via Bluetooth. It can even upload the Arduino code wirelessly. It has a reset signal. And with this board connected, you can actually run code from a remote computer. You don't have to connect this Pi to the board. Just run all the code and send commands through this Bluetooth. And yeah, so it can be even smarter because you don't need to consider how large computer this little robot can carry and how much power consumption it will take. It's all remote.
Okay, so the control board is very similar to your previous control board for like your OpenCAT stuff. Are you developing a slightly better board for the Biddle?
I had the plan to release a brand new board built on the ESP32.
Okay, yes, that's what I was talking. Yes.
Okay. Yeah. In principle, it should bring much better performance, but the development took longer time than we expected. So we do have an upgraded version of our original controller board on the Nibble. You see, this is Nibble V1. No, Nibble V0.
V0. Okay.
Yeah, and we do have this upgraded version called Nibble V1 So we are including this V1 in our current Petoi kit. And we are providing this byteboard based on ESP32 as a option for developers. We can develop all these software together.
Yeah, the cool thing about the ESP32 is that you've got Bluetooth and Wi-Fi on those chips.
Yeah, it's native. Although running all these network protocols may consume a lot of the resources, but as you know, the motion part of my original code will not take too much resources because it could run on Uno. So we think we will still have enough resources if we run the Bluetooth or Wi-Fi connections on the ESP32. And we do have an app developed by our community member. It's called this.
Oh, yeah.
This one, Code and Robot.
Okay. Is that an Android app or?
It's an Android app.
Okay. I'm just curious if it was just all the Android, if it was also on iOS for Apple, for your Apple phone.
Yeah, the developer has designed an iOS version, but on our side, we need to figure out how to connect this Bluetooth dongle to iOS. There is some limitation on the version. So I'm connecting to the Bluetooth, which I unplugged.
Okay. Very cool.
Connect it, done. And you see this play and explore. Oh.
Sort of. But I'm still having a little bit of technical difficulties on my end.
Yeah, so it provides a control panel to play with this dog.
Right.
And by the way, the panel is still showing the cat because the software are compatible.
Okay. Yeah. Yeah, you open cat in the middle. Yes.
Yeah, the software structure is the same, although we do plan to reformat the code to make it easier for people to use or understand.
So, I guess so when you're programming, it's kind of like you have all the motions already there. So if somebody just basically wants to call the individual motions to walk forward, walk backwards, side to side, so on, then for I'm just thinking about how you would do it in Scratch. You have your Scratch-like interface where you can program it where you just have it like move forward, backwards, and sidewards. Can you, in the time remaining, can you kind of demo how you do the Scratch-based programming?
So the Scratch is done by a collaborating company. They are a STEM educational company, and let me see, share screen.
I know how you said that you're not really designed this for kids, but entry-level programmers and people into robotic hobby, that I think they would enjoy the ability to use your Scratch-based or Scratch-like programming environment.
Can you see my screen?
It's choppy. It's really choppy.
Okay, I'm sharing my screen.
Right.
Yeah.
I don't know. We're having some kind of low bandwidth issue.
Okay.
Hopefully the recording is better than what I'm seeing on the screen right now.
Okay. So I designed this robot mainly for developers or people with technical background who is fine with coding in text environment,
Right.
text coding environment. But because it's in such a cute body, people would love to have it extend to some younger people. So this company, they have already built this system for a wide range of bots or robots. If you can see my screen, you can see all the robots it support. And you can find Beetle in their panel, and I can select Beetle. And in this system, you can see like Beetle start, how to set the skills, all this stuff. And now I'm like just dragging all these blocks to build the program. Can you see it?
Like I said, we're having bad issues. I'm seeing something, but it's really slow. It's really choppy.
Okay.
So hopefully it'll make more sense after to people watching.
Okay. Yeah. Basically, the idea is they reformatted the Arduino code into this block form, and they will provide a curriculum to learn programming in this environment. Most of the cases, you can just consider this robot as an Arduino board, because it will cover a lot of basic operations like lighting up a LED, call the buzzer, and in the advanced courses, it will have some motion control section.
See, that's very cool, because I want to commend you on the fact that you're trying to develop some lesson plans and show people how to operate the robot. Because unfortunately, there's a lot of people who develop a robot and try to sell the robot, but they won't factor in or they won't spend the time to do tutorials, lesson plans, and stuff on the robot. So I think that's a really cool thing you're doing to make it easier for people.
Well, I also have that problem. For me, as a software guy, I'm actually more efficient or interested in developing programs, algorithms. As long as I can connect sensors to the robot, I can think about many interesting way to integrate all this to make a smart robot. But the problem is, on the market, there's no good working robot, so I have to make it myself. So now, as a company, I have to keep this company running, generate revenue to feed, to support this project, especially, when we have so many backers waiting for their product. All of our energy are put into the production side. So we will be the last people to enjoy our toy. That's sad.
Oh, that's one of the pros and cons of being a CEO.
Yeah.
So let's, in the time we have remaining, let's talk about some of the sensors. Now, I saw one. Maybe you can talk about this one in particular. You have a camera, right?
Yes.
That you're developing, and the camera is not just a camera. It's also a smart camera, and it does a lot of the vision processing on board, right?
Mm-hmm.
To take off some of the load off the Arduino.
Yes.
So you can kind of talk about that camera setup that you're working on, and so the camera is an add-on, or it's not, doesn't come with the basic Kickstarter pledge, but it is an add-on in the sensor package, right?
Yes, but I also make it as a single pledge you could add on. Yeah.
Okay.
Because this is from our feedback, I think it's a very interesting module. We don't like invent this. It's an OEM or ODM module. We put our brand on it, and we put our special requirement, like the order of the cables and features it should support. So this camera can recognize objects like human body, like balls, like cards with symbols. It can know like the shape, number, and we will include all this deck with symbols. It can be trained to like auto drive or something. And it also has some other sensors on board, like gesture sensor, like waving, and distance sensor, I believe. And it can even stream video while the Wi-Fi connection.
Oh, sweet. So
yeah.
you can actually control it without looking at the robot, is what you're saying. Is what you're saying?
Yeah, you could visit the server on this board through Wi-Fi and stream. But you can only stream when you are doing this because it's not a very strong board. You can It cannot do multiple tasks like streaming while recognizing objects.
Okay.
Yeah.
That is very cool.
Yeah. I think the background is not clean, so it may be laggy, but you see how it tracks?
Yeah, there's a couple boards that I've experimented with that they're very similar to what this board does.
Yeah.
But that's very cool. So I would definitely recommend this add-on if you're doing the Kickstarter, and if you're watching this and you're interested in the product in backing this Kickstarter, I would definitely look at this camera as an add-on because in the beginning you probably won't need it in the beginning, but as you try to make the robot better, improve the robot, add some basic AI and some autonomous stuff, I think the camera would be an awesome add-on. Very cool.
Yeah, this is working. And this hat is also designed as a clip-on structure.
So all the sensors, it looks like you set it up so that you can add all the sensors to the head or the mouth area of the robot. Yeah.
Yes, this hat took me 2 weeks to design. Yeah, all this structure because I want to avoid the use of spring.
Right.
And I'm very happy with the result. And the engineer who makes the mold is also very impressed by the structure because he also considered the ease for manufacturing. If we have small springs in the structure, it may jump everywhere. It may choke kids. So that's it.
Yeah, I like you're very good at designing. I think you're very good at designing injectable parts. I love your idea. Basically, it's a snap together kit. Very little screws, and you've done a really. I think you've done a very good job of designing the body and the parts for the robot. You've kind of put a lot of thought into it, which is very cool.
Thank you.
So I'm hoping that the technical difficulties I'm having will not be seen by the viewers. I'm praying that's the truth because the video is so choppy. And I'm going to do some more experimenting with Skype and learning Skype and seeing if I can improve that for my next Skype interview. But I've taken up a lot of your time. But I would definitely, if you're somebody watching this video, and if you're curious about your Kickstarter, when I post this video on Facebook and online, I'll post links to your Kickstarter. I would definitely encourage people to at least look at your Kickstarter. I personally backed it, and I can't wait to start getting a hold of your robot because, like most people, I've seen the Boston Dynamics Spot and Big Dog and some of their four-legged robots, and I want to have the experience of programming and using a robot like that. And unfortunately, Boston Dynamics robot is just way out of my price range. But your robot fits my budget, and I definitely would encourage people to think about adding on the camera as an add-on, and just from personal experience, they definitely also think about maybe doing the add-on servo pack, so you don't have to constantly be ordering servos. I'm not saying the servos are going to break down quickly, but I know with my experience with robots, it's always good to have backup servos. So is there? Oh, I should know this, but are you having 1 or 2 batteries with the kit?
You mean battery or servo?
Battery. Sorry,
battery. One with the standard kit, but in the research package you can have 2.
Okay.
And let me return to my video. Okay, you see me?
Yes.
So we also customize this battery with a button to turn it on. It's blue because it has charge. If there's low charge, it will turn red. And you can charge it with a micro USB cable. And you can see this plug. You can easily unplug it and switch on because the structure is also slided into the belly.
Right. And it got snapped in. Yeah.
Yeah, you see, get it in and it's on.
And you can actually hear the little. Hopefully, people can hear that. You can actually, when you put the battery in, you can actually hear the sound when it locks in.
Yeah. Yeah.
So another thing that I will commend you on is that LiPo batteries can be a huge issue for a lot of companies, especially when they try to ship them overseas or ship them by air freight. So I definitely commend you in the fact that you have the battery included in the kit. There's a lot of companies now that are not including batteries, LiPo batteries, with their kits.
Yeah, actually, including myself for the previous Nebo. For this kit, we just include the battery holder without the battery. It is really a very big problem. And still, at this moment, I'm still not sure whether it is a right decision to include battery. It's a huge challenge for my company because to make these batteries, we have to order 5,000 units.
Oh, wow.
Yeah, otherwise the factory won't take the order. And of course, there are some technical reasons because they need to get the pairing of the battery cores. They have to have a large sample pool to get the best matching cores to connect them together into this single battery. Yeah, it's very challenging. We need to pay a lot before we make sales. For example, currently, although the Kickstarter is going very well, but we only have 1,000 backers. That means 4,000 units will be staying in our warehouse. It's like a bomb. We don't know when it will explode. It's very dangerous to store these batteries, and also for shipping, we need to go through some certificate. It will take longer time. It will be expensive, and yeah, it's very challenging. But I just want to make a better product with all this better integrated system, and also to avoid confusion on the user side, because for Nebo, some people may find it difficult to decide which is the correct battery.
Yes. See, that's what I'm finding. A lot of companies just not doing this issue and then just not shipping batteries. They're forcing the consumer, the buyer, to go out and buy a battery separate. So I would say, this is just a suggestion on my part, if you could do an battery add-on so that people can order more than one battery with the Kickstarter.
Oh, yes.
That might help.
There. Yeah, it's there.
Okay.
Yeah.
Awesome.
If you like, I don't know which one you backed, But if you can modify your pledge amount, just add the price of the extra battery in it. And after the campaign, we will send out a survey to confirm which add-on items you selected, and we will ship.
Okay, so yeah, if you're watching this video, I would suggest that you you do some extra servos, the servo pack, at least, and maybe consider doing an extra battery add-on too. That would help out you as a person, as a consumer, and it also would help out you in making sure that you can supply the correct batteries for people.
Yeah.
Yeah. Very cool. Very cool. Okay, so we're hitting. Yeah, I love the demo. Watching the demo. I can't wait. Oh, can't wait till I can start playing around with your robot. Okay, cool. I thank everybody for watching. Please check out the Kickstarter. I'll have the link in the descriptions of the video. And please check it out. And if you can, please back it. I think this is a really super cool robot, and I'm very impressed with the thought and all the work put in behind the scenes and the design and development of this. So, okay. So I can stop recording. Thank everybody for watching. Thank you.
Thanks for watching. Bye.
Yeah.